Alright guys, and welcome back. Today we'll be going over the chords, secants, and tangents, and their power theorems. So first thing you want to know is the kinds of lines in the circle. So you probably already know the blue line is the diameter. And then you probably already know that the red line is the radius. And so those are the ones that you guys basically learned already, like in previous years of math. And so the new ones that you guys want to know is the yellow line, which is a secant. So secant is a line that touches the circle twice. So as you can see, it touches it here and it touches it here. So 2 times, goes through the circle 2 times. And then the next one in the green is called a chord. So this one you might have known already with diameter and radius, but it's just basically a secant. It doesn't go out of the circle, it's only inside the circle. And so a diameter is considered a chord. If a chord is lined like that, a diameter is a chord since it touches 2 sides, but a chord cannot be a diameter because a diameter must be like half of the circle, like the semicircle line. But yeah, it's just like that saying, like square is a rectangle or rectangle is a square. I don't remember. I think it's that like a square can be a rectangle, but a rectangle cannot be a square. Yeah, it's like that line, like that quote or whatever. And then the last one is a tangent. So a tangent is just like a secant where it's a line, except it only goes through the circle 1 time, only 1 time. So a secant is 2 times and a tangent is 1 time. And you can remember secant and tangent that they both end with the letter T, and the T is kind of like a line. So yeah. And then also a tangent, like kind of like the way it only touches 1 is like the letter T only touches 1 time at the tip right there. So I think that's a way that you can remember it. So those are lines in a circle, and now let's move on to the next thing. Okay, so now we're going to go over power theorems. So power theorems is basically where it's a combination of chords, secants, and tangents on a circle together, and theorems that will solve for the missing length of these chords, secants, and tangents. So there's 3 power theorems that we want to know. So in geometry. So the first one is going to be chords. So this one right here is going to be a chord plus a chord. So we're gonna have 2 lines intersecting, 2 chords to be specific, intersecting inside of a circle. And that would be an example of this kind of question. And then if we have it like this, then the theorem is that then the product of the length of the parts of 1 chord would be equal to the product of the lengths of the 2 parts of the second chord. So here is a drawn example of what I just said basically. So we can label each part of the chord. So here. So remember, this is 1 chord and then this is another chord. So this is A, and this is B, because, so this is 1 part of the chord, and then like this is another part of the chord, but it's the same chord. Honestly, it doesn't matter what you label it, but it's more easier to label it a consecutive letter if it's the same line. And so same goes with the next line. And so this is C, and then this is D. So the theorem for this, so like I just said, like the product of the 2 parts of the first chord and then the second chord. So then it would be A times B is equal to C times D. So yeah. So let's do an example here where we have 12 here, 10, 8, and then X. We're trying to solve for X. So we know that this is 1 line. And so we can have 12 times X. And then we know that this is the other chord. And so we have 10 times X, or X times 10. Or we can just put 10X. And so we just solve for X. So 96 is equal to 10X. Divide that. And then X equals 9.6. So then right here, this would be 9.6. And so that is chord plus chord, or like solving segment length formed by chords. So that was theorem 1. So theorem 2 is going to be segments formed by two secants. So secant plus secant. So secant is basically the line that goes outside of the circle. So we can have it go this, and then that is what a secant is, and then an arrow at the end. Okay, so we're gonna erase this at the end because it's going to confuse us. Questions won't usually have that. It would just be the secant would just be out on the outside on one side. So we have A here, and then B, and then C, and then D. So the circumference of the circle, or like where lines intersect the circle or the other line, is where the length would be separated, or the parts would be separated. So in here, we're going to also have to label the entire line. So this would be 1, so we can label that E, and then on the other side too. And then, because this formula is going to be A times A plus B is equal to C times C plus D. So basically A and C, basically it's the outside times the whole thing, like so. Outside times whole is basically how you can remember this. So if you see two secants, it would be outside times whole, and then the same thing on the other side. So yeah, but we also labeled the whole line as 1 because it will probably show up like that. So another way to write this entire equation is to say A times E is equal to C times F. So yeah, the outside times the whole line, and then the outside times the whole line. Yep. So that this one is secant plus secant. So this is an example. So basically, again, it's outer part times the whole part, and then same thing on the other side. So we're gonna have 18 times 18 plus x equals 16 times 16 plus 24. That's going to be 324 plus 18x is equal to, so we want to add this, which equals 40, and so 16 times 40. And so now we want to multiply these two. So again, bring the equation down. It's not letting me. Is equal to 640, and then 18x is equal to 316, and so x is approximately 17.56. So that means that is the length of this right here, and that's how we do secant plus secant. And now this last one is an intersecting secant plus, it's going to be a tangent. So this one we're going to label this A, and then this is B, C, and then again, we are going to do the whole thing is going to be D. So the formula for this one is, if you're going to remember that if we see a secant plus a tangent, it's going to have the power of 2 in the formula. So it's going to be A squared equal to B times C plus B, or just times D. So again, this side of the formula is going to be the same thing as the secant plus secant, where it was outer times whole. But since we have a tangent on this one, so this is the tangent, and then this is the secant, tangent's gonna be squared. So it's just something we have to remember, like the formulas and stuff. So that is that's the formula for secant plus tangent. So here's an example. that we're going to do with secant and tangent. So we have the tangent right here. The tangent is equal to x, and then we have the secant. This is the secant right here. So we're going to start. I'll rewrite the formula up here, or since we don't have a's and b's, but this could be rewritten as outer times whole. So we're going to have x squared, since we don't know a, and 16 times 25 plus 16, which is this right here, is 41. And then we're going to multiply those two, 656. And then we want to square root each side to get rid of the square, because we're always doing the opposite. So x equals 25.61. It is probably common for a decimal answer. So, yeah. So that's how you do the power theorems. And thank you for watching.